to start with a very simple formalism. The tip from Turing is that Alan Turing decided to give a theory of what is computation, and he came up with this really simple formalism, a little machine that has a finite set of states, finite set of symbols, some simple transition rules, and it turned out he could prove that any computation could be done by this simple little device called a Turing machine. And that was what launched the theory of computation, computer science. So the idea is, can we do the same thing for consciousness? Can we come up with a simple formalism which will handle all aspects of consciousness? And maybe we can't, but it's worth a try. And so I'm going to give you my intuitions, and the idea is to have a rigorous formalism so that we can find out, where it's wrong. So if we're absolutely explicit, we can see explicitly where we're wrong. So the idea is that consciousness certainly has experiences involved in it, qualia, as they're called, colors and pains and emotions and so forth. We also have the ability to make decisions, actions, take actions, and those will affect the world, whatever the world is, and the world then will affect our experiences. And we can just translate this then into some mathematical symbols. We have a world W, experiences X, and actions G. And the idea is there's a map. I can go into math, it's a Markovian kernel, a perception map, a decision map, and an action map, and an integer counter to count the number of perceptions that you have. And this can be all cashed out mathematically in a different talk. But the idea is a conscious agent is just a six-tuple. X, G, P, D, A, and N. So and then the claim is that, I'll just say those are probabilities based. So this is technical stuff. I'll just leave it for the moment. So here's the claim. Every conscious entity and activity can be modeled by conscious agents. So it's a very clear claim. It could be clearly false. Maybe someone will show that it's false, but the idea is I claim this formalism and networks of conscious agents, as I'll show you briefly, can handle all aspects of consciousness and personal experience. So one hypothesis then about the world is, instead of taking the world to be a physical reality, space and time and physical objects, matter and so forth, I take that stuff to be just our desktop, a species-specific desktop, and let's see what happens if we say that the real reality is just consciousness, conscious agents in interaction. That's the conscious realism. So the idea is that it's an ontology. Consciousness is the fundamental. Now we can have, if we have two conscious agents, we can make, so here they are, agent 1 and agent 2, we can actually take one of these agents and connect it to the other. So what I've done is I've taken one agent, and where the world symbol was, I've plugged the other agent in, because that's the conscious realism hypothesis. The world consists of conscious agents. So what you see is not space and time and physical stuff. It's other conscious agents, and your interface is just presenting you that interaction in space as a space-time desktop. So you can actually have conscious agents, they're linked in a network like this. You can do it more abstractly, a graphical symbol like that, where effectively one is sending information to the other and receiving information. So information is flowing between the two. You can have 3 conscious agents linked together, or linked like that. You can have 4, and in fact, if you think about it, you can have any number of conscious agents linked together in a network, and now you have a very interesting dynamical systems thing. You can have introspection. It turns out if you have 2 conscious agents, the mathematics surprised me. It turns out 2 conscious agents interacting satisfy the definition of one conscious agent. They are also one conscious agent that's introspecting. So what comes out of this mathematics is a model of introspection that's completely rigorous. You can have, so now more abstractly, each dot is a conscious agent. Each link is a connection between conscious agents where they're communicating with each other. You can have arbitrary graphs of conscious agents. And it turns out to be a theorem that given any graph of conscious agents, any subset of the conscious agents constitute a new single conscious agent. Surprising result. So any subgraph is a conscious agent. So the claim then is that conscious agent networks, these networks of conscious agents, first, it's a theorem that they have the power of universal Turing machines, which means that anything that can be computed by your laptop can also be computed by a network of these conscious agents. They have complete computational power. As a result, all the models that we have of, for example, unconscious processing in cognitive neuroscience, Julia Mossbridge talked a lot about the unconscious processes. We have lots of models in cognitive science, mathematically precise models of unconscious processes. All of those models can be re-expressed in terms of the computations of networks of conscious agents, every one of them. Plus, consciousness itself can be modeled. And each consciousness model, a conscious agent network model, is itself a new conscious agent. So each one is like an object-oriented programming language, which is really quite nice. It's a new architecture for thinking about unconscious and conscious processes. Really quite striking. And it's a framework then for all cognitive science models. Now, just briefly, if I start with consciousness, I have to. Am I out of time? 6 minutes. Okay. If I'm going to solve the mind-body problem, I can assume that physics is fundamental, and then my burden is to get consciousness. Or, what I'm trying to do is the opposite. I assume consciousness is fundamental. Then my burden is to show that all of physics comes out of it, quantum mechanics and so forth comes out of this. And it does. So this is an abstract agent dynamics where it's a very simple. Each agent can only see one bit of information, 0 or 1. And you can actually program up these things. This is two agents passing information back and forth, zeros or ones. And it turns out that when you look at the long-term dynamics of these, you'll have to take my word on this. When you look at the long-term dynamics, the states of the two agents become entangled. You actually have an entanglement of this is the title of my talk. Conscious agents actually get entangled because they have different kinds of asymptotic long-term behaviors. And it turns out that when you look at that long-term behavior and write it down, so this is, the top was the conscious agent dynamics long-term behavior. And then if you write down the wave equation for the free particle in quantum mechanics, it's exactly the same equation. So we can actually read off, this is the non-relativistic case, you can actually read off a one-to-one mapping between non-relativistic quantum mechanics and this agent